Hey guys, and welcome to the lesson on scatter plots and correlations. So really we're going to get into more depth with this two variable data in this lesson. So scatter plots represent two variable data as points. Scatter plots may reveal a relationship between two variables or they might not. It just depends on the graph that you get, and we'll see that in our examples. In two variable situations, one variable may be dependent on another. In the words that its value changes according to the value of the independent variable. For example, the value of a car will depend on its age. Typically, we plot the independent variable on the horizontal axis and the dependent variable on the vertical axis. The other thing I try to remember is the independent variable is usually constant in that, like, it moves up at a constant rate. A big example of this is anything to do with time. And then the dependent one does not go up consistently. It varies based on whatever that independent variable is. So be careful when you set them up and that you're picking the right variable to go along the bottom. One of the things we need to be able to do is interpret a scatter plot. So let's do an example quickly and you'll see what I mean. So here we have a scatter plot that has cost on the one side and time required is on the bottom. Notice how time required usually goes up in consistent increments and it doesn't really depend on anything else. Time just is what it is. You can't really change it. You can't go back. You can't go forward. It just keeps going. So that's why it's on the bottom. Jay researched estimates for a job painting his house. The scatter plot shows Jay's results. Question A says, which is the dependent variable? Justify your choice. So the dependent variable is the one that depends on the other one. And so in this case, it's the cost. Why? Because cost depends on time. B, which two companies will take the longest? Which of these is cheaper? So the one that's further out are the ones that will take the longest. So that's these two right here. Which of these is cheaper? So the cheaper one is the one that is lower. So D and E are the longest, with E being the cheapest, or the cheaper one. C, which two companies charge the same amount? So this one I'm looking just at the cost, not the time, and I notice that these two are pretty much the same, B and D. So I'm going to say that B and D are the same amount, or they charge the same amount. Why might you pick company E or company B? So in this case, you might pick company E because it actually is the cheapest of all the choices. Why might you pick company B? Company B, although it takes a little bit more time than A does, it is fairly cheaper. So it's closer to the price of E, but also takes much less time. So B, while not being the cheapest, the time is shorter. And it's only a bit more money. So that is why somebody might choose B over some of the other ones. On to the next slide. It gets into talking about correlation. So correlation is a relationship between two variables. And all of your scatter plots are going to have some kind of relationship. Graphing two variable data on a scatter plot may show a correlation between the variables. If you have what's known as a positive correlation, it describes a situation in which both variables increase together. On a scatter plot, the points go up and to the right. So you see that the points make an increasing type of graph where all the points are kind of going in an upwards direction. The dependent variable is going up as well as the independent variable goes up. A negative correlation describes a situation in which one variable decreases as the other one increases. So notice the independent variable is going up, but the dependent variable is coming down. So you get a relationship where the line kind of goes in this direction. There is also one other, you could say that there is absolutely no correlation. And no correlation just means that the points are all pretty scattered. You can't really tell if there's a trend to it. You couldn't make a line through the points. It's just all scattered about and you really don't see any sort of trend at all. And that's when you would say that there is no correlation. And it's okay to say that. I just don't have an example of it on your notes. Let's look at another example quickly. Analyzing data using a scatter plot. Davis conducted an experiment comparing a person's leg length and how long it takes the same person to walk 100 meters. He gathered these data showing leg length in centimeters, time taken in seconds. So they've given us all the data points, 80 and 66, 73, 74, 60 and 83. The first part of the question said to graph the data. Now I just want you to notice, we've done graphing before. I hope that you know how to graph. But all it is a graph where you have the independent on the bottom, the dependent on the side, and then all you're going to do is take these points, like this one, and plot it. So that 73, 74 is over here at 73 and 74. So it's this one right here, not this one that I sort of attempted to go over, but this top one here. So you'll notice that each one of these points represents one of the points on here. I didn't want to get into too many details about how to graph it because I think that you guys can probably do that. But this is what your graph should look like. Does the graph suggest a relationship between leg length and time taken to walk 100 meters? If so, describe the relationship. So I kind of like for this one, they're kind of really spread out. So, but they're generally coming, they're generally moving down. So they're kind of going in this direction. Whereas if the leg length was longer, the time is shorter. So, does the graph suggest a relationship? Yes. It's not really strong though because, and you can say that, it's not strong because it's kind of still spread out and you don't see a clear picture of it. But generally speaking, yes, it does. If so, describe the relationship. And since it's going in this downward motion, then I would say it's a negative correlation. C, use the scatter plot to estimate the time it would take a person with leg length 85 centimeters to walk 100 meters. So if I'm looking here, 85, I'm going to guess that's going to take around like somewhere about here. So I'm going to guess that it would take approximately 60 seconds. How might Davis make the results of his experiment more reliable? Now, this is a case, generally speaking, when we're doing statistics or any sort of data stuff, the more reliable data has more points. So if I was Davis, I might repeat experiment with more people. Because generally speaking, most data, like if you only have 4 or 5 people, it doesn't really tell you a lot and you can't really see the trend. The more data pieces you have for any sort of stuff like this, the more you have, the better it is to see the trend and actually make some conclusions from it. So if I was Davis, I would definitely ask more people and collect more data. The last piece of it is cause and effect relationships. So even if you observe a relationship between 2 variables and you see a correlation, it does not always mean that one variable causes a change in the other. So you have to think about other factors that might be involved and think that maybe this correlation that you have is just a coincidence and it's not really a cause and effect. Demonstrating cause and effect conclusively is a challenging task that requires careful analysis and specialized statistical tools. So we can kind of guess that it might, but it's not always going to be that because there's a correlation, it undoubtedly means that there's a cause and effect relationship. Let's look at an example to see it kind of in action. So our example says, considering possible cause and effect, state whether the claim in each situation is reasonable. A scientific study showed a negative correlation between aerobic exercise and blood pressure, which meant that as aerobic exercise went up, blood pressure went down. It claimed the increase in aerobic activity was the cause of the decrease in blood pressure. Is that kind of safe to say that that's a cause and effect for that? It seems reasonable. Only because biologically, if people are exercise more, they tend to be a little bit more healthier. So it is possible, but it's not conclusive. Like, there are other reasons that blood pressure could have gone down. So you can say that there could be other reasons. So it is reasonable. It's just that you can't like conclusively say that that's the only reason. You'd have to look at who they actually looked at and who was involved in the study. But it does seem reasonable. B. Mila discovered a positive correlation between gas price and average monthly temperature. She concluded that temperature determines the price of gasoline. So for this one, it does also seem a little bit reasonable. Only because if you think about it, gasoline prices typically in the summer, when the average monthly temperature goes up and it's warmer, people tend to do a lot more traveling, and therefore companies might want to raise the gas price. But again, there also could be other factors. So you have to state that in there. There could be other reasons as well. It's not, again, this one is not all that conclusive. You can't really say unless you do a little bit more, but it does seem reasonable. Last one. Since the 1950s, the concentration of carbon dioxide in the atmosphere has been increasing. Crime rates in many countries have also increased over this time period. Does more carbon dioxide in the atmosphere cause people to commit crimes? Now, just reading that, use your common sense, guys. it seems a little bit ridiculous that carbon dioxide would have an effect on crime rates. So, for this one, it doesn't seem reasonable. There could be way more factors than just the carbon dioxide in the atmosphere that causes crime rates. And so blaming it on carbon dioxide is not really, it just seems ridiculous. So use your common sense with these ones. You can't really conclusively say that with this one. That's kind of it for today. I know it was a little bit a lot, but it'll make more sense when you guys do the practice questions. Why I wanted to go over each little thing, because they all kind of combine together. It's not that it's particularly hard lesson for today. It's just that it does have a lot of different pieces, and I wanted to make sure I went over them. Have fun with the practice stuff, and I will see you guys later.